or how to implement this list in programming. There are two different ways. One is we can use array. We can use an array to implement a list. Okay. So what is an array? You all already, I think, you all already aware of array, but I am defining this in this way. Array is a set of homogeneous elements stored in consequent memory locations. You have to note down these two terms perfectly. Homogeneous elements means all the elements of must be of same type. Consequent memory locations means all the values has to be stored in uh, neighbor memory locations. For example, let us say I have an array, namely A, and its size is, let us say, 8. That means I can keep 8 elements in that array. So the memory for that A will be allocated priorly. So here the memory for A is allocated. 65230 is address of the first element, and as I told you, I'm storing an integer value. So the next address may be after 2 bytes, because integer occupies at least 2 bytes. Okay, in our sense, if we assume that integer takes 2 bytes, then the next memory location will be 65232. Then the next memory location will be 65234. All these are consequent memory locations, I mean side by side, and all the values to be stored in an array will use these consequent memory locations. That is why array can be defined like this. Array is a set of homogeneous elements, so all are of integer type here in this example, and stored in consequent memory locations, so will be stored in the consequent memory. So this is how we define an array. But in the implementation, using array is having some drawbacks. Okay, suppose let us say I have 1 lakh elements. So for 1 lakh elements I have to declare array of size 1 lakh. Okay, so that much memory will be used, and that much memory must be using consequent memory locations. That means that much memory must be free with consequent memory locations in your computer. Otherwise, you cannot use that array. First thing, availability of memory is definitely a difficult one for storing elements in consequent memory. Number two, suppose let me take the same example as we have shown. I want to insert a new element in the first position. Okay, here a of 0 is the first element, a of 1 second element, a of 2 third element, and so on. Assume like that. Now I want to insert a new element in the a of 0's position. Okay, which is already having some set of values. Let us say 10, 20, 30, 40, 50, 60, 70 are already there. I want to insert 80, but in the first position. What should I do? I have to right shift all these elements, then I have to free the space for the first element and insert it. Okay, see, when I want to do that, when I want to insert here, okay, what I'm doing is I'm shifting this to the next memory location, and the sixth element to the next position, fifth element to the next position, and so on, so that I can shift the first element to the second position. Okay, after doing this, I can make room for a new element here and insert a new element here. But assume that you have 100 elements in this array, and you want to insert a new element in the first position. You have to shift all 100 elements. If you have 1 lakh elements, you have to shift all 1 lakh elements to the right. So definitely it takes more computational power and time, CPU's time. Okay, so definitely it is not a good practice for insertion and deletion. Then what could be the alternative? Okay, what could be the alternative? That is, suppose if you have some memory, computer memory, okay, where you have some free spaces. Let me assume that these are free spaces. Okay, not consequent spaces, but some free spaces in your memory. Then I have a value in my hand, then I have to store it in this free place. If I have a new value, I have to store that in the another free space. If I have a new value, I have to keep it here. If I have a new value, I have to keep it here. Like this, I have to keep the new values in the memory wherever you find space. Okay, so if this is possible, okay, definitely that could be a more flexible process of storing a set of elements. Okay, so this is a drawback with arrays, and the list will solve this problem. Okay, similarly, to utilize array, you have to declare the array first. What I mean to say is, suppose if you want to store the names of the employees, okay, if you declare an array of size 50, if the company gradually increases the number of employees, okay, then if the company want to recruit 10 more people, then it requires 60 spaces. Okay, so if you are aware of this, you have to declare an array of 60 size. Okay, if you are unaware of this, you have to declare it with 50, then you will not be finding room for the further 10. Okay, so it is a little difficult for any programmer to assume the size of the data. We cannot assume the size of the data because, for example, if I want to do large data processing, so the data processing on large amount of data, okay, so whenever I get data, I'll keep it in memory. So I cannot determine the size of the data, the number of elements to be stored. At that time, suppose if I am storing 1 lakh elements for some process and only 100 elements for the same process, I cannot use the same program for both, because for 1 lakh elements, I have to declare an array with 1 lakh size, and for 10 elements or 100 elements, I have to declare an array with that number of that size. So the same program cannot be used for all these purposes. That is why arrays is not feasible to store the to process on list. Array is not feasible to process on list when you are unaware of the size of the list. Okay, right. Now what is an alternative? Let us see the alternative. Okay, linked list. Linked list is an alternative for this. Okay, how could you define this linked list? A linked list can be defined like this. A linked list is a common data structure, okay, made of chain of nodes. Please notice down. Chain of nodes, okay, and each node consists of value and a pointer. So I can define a node like this. A node consists of value and pointer. Means we are having a single variable which can hold two values. Is there any possibility in C programming to realize this? Yes, you are right. Structures. Structures can be used to store different data, I mean different types of data as a single unit. Okay, so here I will declare a node as a structure which consists of one variable for value and another one for storing the address, a pointer variable which can hold the address. Okay, so now let us say I have a node, I have created a node, and I stored a value in that node. Okay, and initially let us say okay, fine, I have taken another node and kept a new value into this 20. Okay, and I have taken another node and kept a new value into this 30, 40, 50. Like this, whenever I want to store some value in memory, I will create a node and put value in that. And most importantly, I will do this, that using this pointer, I will store the address of the new node here. That means in the previous node's pointer variable, I am going to store the address of the new node. Similarly, address of this node will be stored here. Like this, I am going to establish a link. Okay, I'm going to establish a link between the nodes. Right. Now, a end node, that is the last node, always consists of the address as null because there are no further nodes. Right. And always first node can be called as head. It will be always called as head because we always start traversing through this link from head. Okay, so head, we will start from head and travel to the next node because we have the pointer of next node, address of the next node. From here the next node consists of the address of the next node. Like that we will travel to the last node in a linked list. Okay, so here you are having links between the nodes. That is why we call it as linked list, a list with links. Okay, Now definitely you'll get this question. For arrays, we usually declare an array, suppose int a of 10, so that memory for a will be allocated and we will use it. But how could we implement the linked list, right? So we will see that step by step. Okay, so first of all, let us see this. In the linked list creation, the first and most important step is creation of the node. So node, how a node can be created. Here it shows the declaration of the node. Okay, so I already told you node consists of one member for data and one member to hold the address. And surprisingly, which address will be stored in a pointer? Here in the previous list I shown that the address of the same node type. I mean, suppose if I create a new node, that is also the same type, right? So address of this node type only stored. That is why I am declaring it as struct node store next, because this pointer is of type the same structure. Okay, this is called a self-referential structure. This can be called as a self-referential structure, right? Now this is how I declare a node. Okay, I forget about this. I am also creating a pointer variable of type node to hold the first element, that is head. This is a declaration of that. Now I hope you understand this node creation. Now we will go with the further discussion. Okay, right? After creating the node, what I mean, after declaring the node, what will we usually do? We will create the node. Okay, what do you mean by creating a node? Allocating memory for that node. Okay, so you are having a mlog function to allocate memory for this node. Okay, so we are allocating memory for a node using mlog function. And you know the syntax of the mlog. Here you have to keep the type of the pointer to which you are allocating memory. So typecasting, you are doing typecasting here. So you are writing node struct node star. Okay, and the memory allocating for the struct node. Okay, so this is the statement, memory allocation statement to allocate memory for one node. Okay, if you want to create another node, you have to run this code another second time. Okay, you have to create a new node, you are always required to allocate memory for a new node whenever you want to create a node. Allocating memory is nothing but creating a node. Okay, right. Now what if that memory is not available in the I mean, that required amount of memory is not available in your computer? If memory is available, memory will be allocated by the malloc function. If memory is not available, then malloc function will return null. So we always, after creating a node, we always check whether the memory allocated or not. If memory is allocated, okay, we will go forward and do the further process, whatever we want to do. If memory is not allocated, we have to stop doing here itself, because there is no memory for us, okay, in computer. So to check that, we have to test whether malloc function returned a valid address or null. If malloc function returned a null, you just display, for user understanding, you just display that memory cannot be allocated and you can quit out from the program. Okay, right. For our understanding, let us assume that this malloc function allocated a valid address. Okay, so allocated successfully, memory successfully. Then what will we do? Okay, so whenever this malloc function allocated memory, then we will input a value into that node. Here, see this here, what we are doing here in the value place. Okay, we are going to keep the value. Okay, so for that I am reading a number. Okay, after reading a number, what should I do? After reading a number, I have to do this. What? I have to keep that number in the corresponding node. And what is the address of the node head? So in this structure, to access this data through a pointer variable, you have to use this arrow symbol, right? So head arrow data represents that the data belongs to this particular head pointer. So head data num is equal to num means what? The number value, suppose if you enter 10 here, okay, this 10 will be stored in the value position. Okay, and what is what does this pointer contains? There are no further values, and this is only the first value. That is why I used head as a pointer here. So when it is a first value, okay, the pointer must consist of null. That is why I am writing head next. Head next is equals to null. So here whenever I write head next is equal to null, you are having only one node which consists of 10 as value and next as null. Okay, so for one value it is okay. But if I want to add few more elements to this list, okay, then what should I do? Whenever and remember this, I forgot telling this. See, I am using another new pointer called the last. We have to declare it clearly as a struct node last. Okay, and last is equals to head. You have to write this because this is a head node as well as a last node. This is a head node as well as a last node. That is why I took another new pointer and I placed last is equal to head so that both are pointing to the same. Now, if you want to add more nodes, what will you do? Follow this code. Okay, what is happening here? What is happening here? See this code carefully. So I took a new pointer because I should not read a new value into head always, because head points to the only first node. So I took a new pointer and allocated memory for that. Okay, so that a new node is created. This is the new node created. Okay, and I took a value, a data value using scanf statement into a variable num, and that value is transferred to data, new node data. Then 10 is placed here. Okay, 10 is placed here. Then what I am doing is I am assigning null to the new node because new node is adding at last 10. So I am adding new node next is equal, sorry, I forgot telling you that this node is already created. I am extremely sorry for making this confusion. See, this node is already created and we are creating a new node. Okay, we are creating a new node. Okay, fine. Now here whenever you allocate memory, a new node will be created here. A new node will be created here. I will show that graphics in the next point. And let us assume that I took a new value 20. Okay, now what is the new last node? This is the last node. This is the last node. Okay, so after doing this, I mean assigning value, I have to keep null in this last node because there are no further nodes. And now I want to establish link between these two. Okay, so how could I establish link between these two? Last node, I mean previous last node is this, right? So last node next, what is last node next? This room. Okay, I'm writing last node next is equals to new node, that is address of this node. Okay, so that this link can be established. Now this link is established. Okay, and now you have two nodes, right? And definitely this node is not last node. Now after doing all this process, this node is last node. Then I have to make this node as last node. Okay, so how to make this node as last node? You have to write last is equal to new node. Then this node will be replaced and this last points here. Okay, now see this in graphics. See, a new node created and that new node is pointed as last node with the same code. And assume that I want to create one more node. The same code will be repeated. Okay, so definitely same code will be repeated means what? A new node will be created, value will be taken from input. You are assigning that value into data part and we are putting null into the new nodes next, and you are making that new node as last. I mean you are linking the previous node and a new node, and you are making the new node as last node. These are the steps. Okay, so let us see whether this is happened or not. Right, similarly if I create a new node, again I have to run all this code. I have to run all this code one more time. Okay, so I have assumed that I have created this, I have done all this code one more time, executed this, then a new node is created. So this is how a link will be established. Okay, everybody will get a doubt about this, that how to get these values. Okay, fine, you have stored all values in memory. Okay, but if I want all these values to be displayed, what should I do? Okay, so now we will see that also. displaying elements of a linked list, displaying elements of a linked list. Okay, so for this I am also taking a new pointer called a temp. Okay, so I will start from head and travel through all the nodes till I encounter last node. But how to recognize the last node? So last node can be recognized with this. What? With null. Whenever I encounter null, okay, I will stop processing, because that says that I have reached the last node. Okay, so now what I am doing is this. What is the initial value of temp? Head means head pointing this. I mean temp pointing this. Okay, and definitely temp is not equals to null, because I have a list with 4 elements, right? Now I am displaying the data in that, that is 10. So 10 is displayed here. Okay, then what I'm going to do is, I am in general for loops, you used to do I is equal to I plus 1, right? That is I plus plus. In such a way, I am going to make temp is equal to temp next. Means actually the value in this memory is called temp next. I'm going to assign that value to this temp, means temp will point to the next node. Okay, so I'm writing temp is equal to temp next. Right, now see what will happen if I do that. This temp will point to the next node, and same as before, I'm going to display temp data, that is 20. Okay, and what will I do again? I will move to the next node and display 30, and I will move to next node and display 40. Okay, and when here in this condition, now temp is pointing this, and at the after displaying 40, that is temp data, after displaying this, I am going to write this temp is equal to temp next. So if I do this, I mean if I write temp is equal to temp next, right? Temp next is null, so null will be assigned to temp now. Now in the next iteration, I'm going to compare the while loop, that whether temp is not equals to null or not, and temp is equals to null, so this condition will get failed, so that you will come out of the loop. So the process ends here. Now you have displayed all the elements of the list by traversing from head to tail or last element. Okay, so this is how we usually create a list and display elements of a list. Okay, right. So this is end of the today's discussion. If you have any doubts in this topic, that is creating a list and displaying elements of the list, you can mark your question in the comments section, so that I can explain you there itself. Okay, and you can also mark a mail to me. My mail is already shown in the first slide itself. You can mark any query if you have in through the mail, and I will try to reply it. Right. Thank you very much for patient listening.